In this lesson, we will discuss the critical path method. This is going to be a jam-packed lesson with a lot of very important information and techniques. I want you to follow through this lesson and then feel free to pause at any point of time, practice on your own with a pen and paper, and also rewind and watch as many times as you want. Using the critical path method, there are several important things that we will calculate on the schedule. And these are, one, the activity dates for the entire schedule can be calculated using the CPM. The second is we identify a critical path amongst several paths in the schedule. We will also find the float or slack for the entire schedule and for individual activities. This is a period of time that an activity can be delayed without impacting the entire project. And most important, we will also find the completion date for the entire project and how it can be protected using the CPM. And last but not least, we identify risky activities and activity paths in the schedule by the convergence and divergence points. So without further ado, let's proceed. First, let's recap on how a network diagram looks. On the screen, I have got a very simple network diagram. We have already done this, but I will just quickly recap. These boxes that you see here, we have 1, 2, 3, 4, and 5 boxes. These represent activities, individual activities or tasks. It can be anything like create the project charter, technical design, develop, testing, and so on. It can be any activity. And these arrows you see are dependencies, and B is dependent on A for it to begin. And you can also see convergence, and this is a convergence point and this is a divergence point. So what this basically means is that C and D activities are both dependent on B. And without B being completed, we cannot begin C and D. Okay. Similarly, this is a convergence point, and E cannot begin until and unless both C and D both have completed. So that is the way it is interpreted. This network diagram always has a start point and a finish point. It's mandatory. And our goal is to go from the starting point to the finishing point along these paths. C and D are parallel paths. It is possible for both to be under execution at the same point of time. One more point that is important to note is that you should never go in a loop. Loops are prohibited in a network diagram. So don't do something like A, B, C, E, and D. That won't happen. Okay. So next we will see how to calculate and identify a critical path. We can see that there are two paths in this network diagram, and that is A, B, C, and E. That is one. The first path is A, B, C, and E. And the second path is A, B, D, and E. And then both go on to finish. How do I identify the critical path? The critical path is nothing but the longest path, and that will determine the duration of the entire project. Let us add up the durations. This number here, I should have mentioned earlier, represents the duration of this individual activity. So task B, for example, this will take 3 days. It can be 3 days or 3 hours or whatever. We are not looking at the unit of time. And activity A takes 4 days to complete. C takes 5 days to complete, and so on. So let us look at the durations of individual paths and identify which is the biggest of them. A, B, C, E naturally would be A is 4 days plus B is 3 plus C is 5 plus E is 3. So the total comes up to 4 plus 3, 7, 5, 12. 12 plus 3 is 15. This comes to 15 days. And A, B, D, E is 4 plus 3 plus 4 plus 3, 7, 11, 14. A, B, C, E, because it is longer than the other path, this is your critical path, okay? And it is 15 days in duration. Let me just highlight that. This is your critical path. And here we have a divergence point and here we have a convergence point. The next step for us is to understand the standard convention that is used in analyzing this critical path. You can see this here, and this is exactly what is prescribed in the PMBOK. There are several conventions, but this is the internationally accepted standard convention to represent an activity. This is the same as the boxes that we were using so far in our diagram. We'll continue to do so. Now, every task typically has some bandwidth. For example, if a task is scheduled to start on a certain day, anything can happen. It may get delayed, but some tasks, like we saw earlier, can have a bandwidth, especially if it is not on the critical path. Tasks on the critical path do not have freedom to be delayed. Any delays on the critical path will result in a delay for the entire project. But there will be tasks not on the critical path which may have some bandwidth to be delayed without impacting the entire project. And that is called as a float. Okay. Float is, in some texts, it's also called as a slack, and it is also known as total float. And they all mean the same thing. This is the amount of time that an activity can be delayed without affecting the project finish date. For example, if I go back here, you can see that this task D can be delayed by 1 day without impacting the total finish date. So how is this represented in a network diagram? There is an early start. This is an early start day when this task starts, and an early finish day. Here you can see this 5 here represents the 5th date in the schedule, and 3 is the duration you can see here. And this is the early finish, that is 7. The task is designed to complete on the end of the 7th date. The early finish is the start of the 5th day and end of the 7th day. All of the 5th day, all of the 6th day, all of the 7th day, that is the 3 days duration of the task. The task can allow 1 day of delay without impacting the entire project. That is the total float of this particular task. It has been delayed by 1 day. Then the late start becomes the 6th day. The beginning of the 5th day is the early start, and the beginning of the 6th day is the late start with a delay of 1 day. Okay. And if it starts on the 6th day, then it will proceed for 3 days. That is the entire 6th day, the entire 7th day, and the entire 8th day. And that's why we get the 8th day as the late finish with a duration of 3 days for the task. And float, that is float here, there is a formula for this. It is late start, that is this late start minus the early start. 6 minus 5, and that is 1. That is the float. And you can also do this with the finish dates. That is the late finish 8 minus early finish, that is 7, you get 1. Now this will all make sense in the next step when we deduce this for the entire schedule. So if you are a little confused right now, don't worry. In the very next slide, it's all going to make perfect sense. Okay, so now we come to the next step of the critical path method, where we will deduce the dates, start and finish dates for the entire schedule using the CPM technique. And in the first step, this will be in 2 steps. That is the forward pass, where we will go from the start to the finish, and then we will do a backward pass where we will go from the finish back to the start, and this will give us all the possible dates for this schedule. The entire thing is called as critical path method. Now we are going to do the forward pass. So I have to start from the start point, and remember that these numbers in red represent the duration of the tasks. We always start on day 1. I will start on day 1. And task A requires 4 days of duration to be executed. So what will be the finish date for task A? It will be all of first day 1, all of day 2, all of day 3, and all of day 4. At the end of day 4, this task will be completed. Task A has completed, and we have to go to task B. Because task A took all of day 4, this can only start on the next day, which will be the 5th day of schedule. And this will need 3 days of duration. Now you should tell what will be the completion date here. It will be all of 5th day, all of 6th day, and all of 7th day. Now, is there an easy way to compute this? Yes, there is a formula for this. Early start plus the duration minus 1. That is the early finish. So 5 plus 3 minus 1, 8 minus 1 is 7. This is a formula you can use when you are dealing with larger numbers in real life projects. Just observe here that we have a divergence going here. So completion of task B will trigger the beginning of task C and D at the same time. These two will run in parallel. How do we calculate this? This ended on the 7th day, naturally. The early start for task C will be the 8th day. And the same for task D also. Now 8 plus 5 is 13 minus 1 is 12. And when will this complete? 8 plus 4, 12 minus 1 is 11. Now you have to pay a lot of attention because this is now a convergence point. You have to think very carefully here. When will task E start? Remember that both C and D have to complete before E can be started because E is dependent on both C and D. Now, naturally, this can only start when the bigger of these two completes. So, which is the bigger finish date for these two tasks? It is 12. We will take 12 as the input here, and one day after 12 is 13. Task E can only start on the beginning of the 13th day. And what will be the finish? 13 plus 3 is 16 minus 1 is 15. This is also the duration of the entire project. Schedule is going to take 15 days and this is the critical path also. Quick check, you can say it's 15 days. And this, what we have done now, this is called as the forward pass because we went in the forward direction starting from the start point and going to the finish date. And we found the duration of the entire project and I'm just going to circle it here, and this is the completion date for the entire project. Now, in the next step, we are going to go in the backward direction, and going in the backward direction will give us the late finish and the late start and the float for any individual tasks. Now, we will calculate the backward pass. The most important point to remember about the backward pass is that everything that we did so far in the forward pass, we are going to do that in reverse. The technique is to do the complete logic of backward pass in reverse. So we are going from Friday back to Monday, Friday, Thursday. So the days that we calculate now will go in reverse. Okay, I will show how this is done. Remember that for the forward pass, we started with the day 1 because that's when we will start the project. But when we go in a backward pass, we will start from the end day, that is 15. Now, if 15 is the late finish of this task, what will be the late start? And to do that, we will first subtract the duration and then add 1. This is the reverse. 15 minus 3 is 12 and plus 1 is 13. Remember that this was a convergence point and we have to find the finish dates for C and D together, and our input for that will be 13. In the forward path, we were adding 1 day to go ahead. Now we will subtract 1 to find the finish dates of these two tasks. So 13 minus 1 is going to be 12. And here also it's going to be 12. 12 minus the duration is 7 plus 1 is 8. And here I have a simple formula to calculate the late start for any activity. So it is going to be the late finish LF minus the duration plus 1. That will give you the late start for any task. So let's apply that again. 12 minus 4 is 8 plus 1 is 9. The late start for activity D is the 9th day. Now we come to a divergence point here. This is dependent on C and D. When we were going in the forward pass, we took the bigger number of these two, right? And now we have to take the smaller number and subtract it by 1. So the between 8 and 9, the smaller number is 8, and subtract 1, and that becomes 7. Just remember, it's exactly opposite to the forward pass. Now, how do I find the finish? 7 minus 3 is 4, plus 1 is 5. And subtract 1 again, 4. 4 minus 4, 0 plus 1 is 1. Now, let me also calculate the total float for each individual task. If you remember, the total float for any task would be the difference between the late start and the early start. Okay, so 1 minus 1 is 0. This has a 0 float. And here also it is going to be 0. 8 minus 8 is 0. However, 9 minus 8 is 1. So this task D has a total float. This can be delayed by 1 day without impacting the finish date of the total project. And here, of course, this is 13 minus 13 is 0. Now, just observe that this is the critical path. We'll just highlight the critical path. Okay, so this is the critical path, and just observe that every task on the critical path has a 0 total float. So what I would like you to do is draw this diagram on a piece of paper and manually redo this exercise. It's very important that you practice. What can you expect on the exam? Earlier exams had complicated schedules which you are required to work out everything that we have done just now, finding the critical path, different paths, total duration of the project, float on individual tasks. But this is no longer the case. The recent trend is that there will be no numerical calculations, but it can change. This is a very simple concept. All that you need is practice. And as we are coming to the end of the lesson, I want to conclude with one more concept called as free float. Earlier we had talked about float, just float, or total float. This is a little confusing. Free float is calculated for individual activities, and total float was for the entire project. Free float of any individual activity is the amount of time that it can be delayed without impacting the total duration of a project. It is important to know the free float of activities while a project is in execution, because it can help you handle unexpected delays on the project while it is in execution. You will have some precious bandwidth while dealing with unexpected contingencies on the project. There is a simple formula for this, and that is, for any activity, to find the free float, which we can call as FF, it is the early start of next activity minus the early finish of current activity minus 1. And let us do this for a couple of tasks so you can understand how this is done. For task A, the free float would be the early start of the next activity, that is for B, that is 5, minus the early finish of current activity, that is 4, 5 minus 4, minus 1. So 5 minus 4 minus 1 is 0. So the free float for task A is 0. And for B, it will be the early start of next activity is 8, minus early finish of current activity, that is 7. 8 minus 7, sorry, I have written 7 minus 8 here. 8 minus 7 minus 1 is 0. Now for D, we get early start of next activity is 13 minus 11 minus 1, that is 2 minus 1 is 1. Task D has a free float of 1. And in the next slide, here is a practice activity. So what I am going to do is I am going to work this out very quickly so you can see how easy it is. You might also want to replicate this diagram now, practice it yourself, and I'm going to do the forward and backward passes on this. First step is, let us find what is the critical path. There are again two paths. Remember that in your real life schedule, there may be 2 paths or 5 paths or 10 paths. Complicated schedules will have multiple number of paths. And all of this in today's world can be done very easily with tools such as Microsoft Projector. You will no longer be required to manually do any of this. However, you should know all of this to be able to design a proper schedule. Your PMP exam reflecting that is not going to ask you to do all of this manually anymore. So first step, let us find what is the critical path. Now the critical path, we have 2 paths, that is A, B, C, E and G, and one more path A, B, D, F and G. Now A, B, C, E, G will be 5 plus 3, 8, 8 plus 4, 12, 12 plus 3, 15 and 6, 21. Okay. Now for the other path, 5 plus 3, 8, 8 plus 7, 15, 15 plus 5, 20, 20 plus 6 is 26. So this is your critical path. Okay. And total project duration is going to be 26. Now let's do the forward pass on this schedule. We always start from day 1. This is the early start for task A. And what is the early finish? 1 plus 5 minus 1. So that will be 5. So task B can only start on the 6th day. And what is the finish for this? So all of day 6, all of day 7, all of day 8. So 8. And now this is a divergence point. C and D are both dependent on B and it can only start the day after. They will run in parallel. So this will start on day 9. Both of these will start on day 9. When will it finish? 9 plus 4 is 13 minus 1 is 12. So this will end on day 12. And this is 9 plus 7 is 16 minus 1 is, this will end on the 15th day. E is only dependent on C, so this can start on the 13th day. And when will it finish? 13 plus 3 is 16 minus 1, 15. Task F will start on the 16th day. And when will it end? 16 plus 5 is 21 minus 1 is 20. So it will end on the 20th day. Now we come to a convergence point. Remember, in the forward pass, G is dependent on E and F, and it cannot end until the larger one of these two have completed. So the larger date on this is 20. So G can only start on the 21st day. And when will it end? 21 plus 6 is 27 minus 1 is 26. The entire project is going to end on the 26th date. Now we will do the backward pass. The late finish for this is going to be 26, and now we will do everything we did in forward pass in reverse. So I will subtract the duration and add 1. So 26 minus 6 is 20 plus 1 is 21. 21, and to go ahead I have to subtract 1. This is going to be the late finish of E is going to be the 20th day. Exactly the same for F also. So now what is the late start? So that is going to be 20 minus 3 is 17 plus 1 is 18. For activity F, 20 minus 5 is 15 plus 1 is 16. And for D, late finish is 15. 15 minus 7 is 8 plus 1 is 9. And here it is 17. 18 minus 1 is 17. 17 minus 4 is 13. Plus 1 is 14. We come to a divergence point. We have to take the smaller of the two start dates, that is 14 and 9, which is the smaller 9, subtract 1 to go ahead. So this will be 8. 8 minus 3 is 5, plus 1 is 6. Going to task A, 6 minus 1 is 5. 5 minus 5 is 0, plus 1 is 1. Come back here. Now we can also find the slack on the individual tasks. Here it is 1 minus 1 is 0. 6 minus 6 is 0. 14 minus 9 is 5. So we have 5 days of total slack here. And 9 minus 9 is 0. There's no slack because it's on the critical path. 16 minus 16 is 0. This is also on the critical path. 13 minus 18 is 5. You can see the total slack. The total slack will be the same on the path. Okay. So there is no slack on this activity G. That about completes this. Repeatedly telling, please practice this exercise, understand the concepts well, and redo this lesson again 1 or 2 times if you want. I have packed it all into this lesson so that you get a free-flowing exercise. And with that, we come to the end of this lesson. I will do one more practice lesson coming up next.